Morning, everybody. Apparently my choice of shirt today wasn't the best. It's a little too close to the green. I should have thought about that. Anyways, guys, if you can hear me, see me, throw some green checks in there, and we'll get started here in a second. Hopefully everyone's doing okay today. A couple of you had a chance to get in your Unit 1 learning guides last night, and I had a chance to go through those before I left here and sent off some passwords. So a couple of you are ready to write that Chapter 1 test. I was hoping that everyone would be ready to write that at the end of today. So I'll leave work here probably around 3:34. If you could get your learning guide submitted by then for Unit 1, I'd be happy to go through it, and then if you have that password for the test, you can just write it whenever you want. So it's kind of my hope. Just waiting on a couple check marks. Kind of funny how you guys get in and you just get comfortable and you're like, oh, Mr. Borden's talking, and then just kind of forget about the green checks. All right, what I was gonna do is I was just gonna jump right into Unit 3, Lesson 1. And then if I have some time at the end, which I will, if you had any questions about the Unit 1 stuff that we're working on, you could go ahead and ask those. So there should be time at the end. This won't take very long. So I'm just going to get into it. Nobody's really written anything in chat that's entirely pressing. I got lots of green check marks, missing a few from like Haley and Shayna just got in here, so give that up. Okay, so Unit 3, Lesson 1, multiplying and dividing terms with exponents. This is actually stuff that you did in grade 9, so hopefully you remember it. Of course, now that we're in grade 10, they're going to kind of notch it up to the next level and make these questions a little bit more challenging, but the same principles apply. This whole unit's really quick. I'm hoping to be done it in like 3 or 4 days, so if all goes according to plan, I'd really love to get it done in 3 days, but that might not be possible. So basically all of the questions in this unit, Unit 3, involve dealing with exponents and exponent laws. So at the very beginning, we start kind of slow and we introduce one idea, and then we introduce the next idea. And then the last section is just all the ideas together in these big, massive, jumbled up problems. And I kind of like them because I kind of look at it as a little bit like of a challenge, but I'm kind of a dorky math person. So if you approach it that way, there you go, applying the laws and working through it. Some of us may get overwhelmed with these types of problems, but it's just important to remember that you just need to break it down a step at a time, and they should work out for you. So the first thing here, recall from grade 9, when we multiply terms with the same base, we add the exponents. When we divide terms with the same base, we subtract the exponents. So we have our two kind of laws, we'll call them, just in general terms, here and here. So multiplying. Now this is just a general form. Anytime we're multiplying numbers with exponents, whatever the exponents are, as long as they have the same base, that's the key here. You notice the example, we used the letter A. As long as you have the same base, you can add the exponents together when we're multiplying these things. So you can see a to the power of m times a to the power of n equals a to the m plus n. And then when we're dividing, same deal. As long as your bases are the same, they're a's or x's or 3's or 7's or whatever, you have m on the top, n on the bottom, you're going to go m minus n. Or you can write it this way, kind of horizontal, vertical. We can write division 2 different ways. So let's look at just really basic examples here. The first one here, I have 7 to the power of 2 times 7 to the power of 3. And if we think about this, if I have 7 to the power of 2, that just means 7 times 7. And then if I have 7 to the power of 3, I have 1, 2, 3. So how many 7s do I have? Well, in total, there should be 5 there. So I get 7 to the power of 5. I could, and I will, always write it this way. I'll write it as 7 to the 2 plus 3 equals 7 to the power of 5. So kind of 2 different ways to do the same problem. This is really what's going on with the math, and then when we do it this way, it's just a little bit shorthand way of writing that. You guys remember this stuff? Is this ringing any bells? You recall this from grade 9? Get a little like thumbs up, a nod, a green check, anything. Anything to say, yeah, I kind of remember this. A little bit, vaguely. Perfect. Good. Everyone seems to recall this. And then Taylor asks, m and n equal 1. M and n, say those two quickly. M and n could be any numbers. They're just variables. They could be 300, they could be 5 million. It doesn't really matter. Generally speaking, they're all going to be numbers around like 1 to 10 for the questions we do. So that's that. The second one here is division. So if I had 2 to the 5 divided by 2 to the 3, that would look something like this. I'd have 1, 2, 3. Oh, I don't want a 3. I want another 2. Another 2. 1, 2, 3, 4. 5 2s on the top. And then I'm going to divide by 3 2s. 1 times 2 times 3. Now, there's 2 to the 5 divided by 2 to the 3. This 2 divided by this 2 is just going to give me 1. This 2 divided by this 2 is just going to give me 1. And this 2 divided by this 2 is just going to give me 1. So what I'm going to be left with is 2 to the power of 2. And I'm happy with that. 2 to the power of 2. I could write it over 1 if I wanted. I don't always need to. So what I usually would just write it as 2 to the power of 2. The alternative way, the way that we're going to do it in grade 10 is I would write it, I'll just write it down below here in red. I would have 2 to the power of 5, and then I would subtract 3, which gives me 2 to the power of 2. So I end up at the same spot, doing it both ways. This is kind of the tricky one, because you'll find that these exponents of 0 kind of get thrown into questions. You'll be doing some division or multiplication. All of a sudden you'll end up with something in the power of 0, and then you'll just keep on using it. And you forget that anything to the power of 0 is equal to 1. Does anybody remember why something to the power of 0 is always equal to 1? It might be hard to kind of convey that in chat, but if you remembered why, you give me a hint. Maybe your Math 9 teacher went through that with you. It's kind of a handy little law to have, because it a lot of times cleans up these problems really nice. You have this big mess of stuff, and all of a sudden you have an exponent of 0, and you'd be like, oh, that's just 1, that's easy. Zero to the power of 0. Whew. It's a tough one. Just trying to think. 0 to the power of 0. That's still going to be 0. That's a really good question, Alex. So we have an exception to our rule. I guess anything to the power of 0, as long as it's not 0, is going to equal to 1. Makes sense. It has to do with the division rule we just looked at. Let's say I had something like, I don't know, x to the power of 7, and I divided it by x to the power of 7. If we think about our basic math, if I'm dividing something on the top by the bottom, and they're the same thing, x to the 7 and x to the 7, these are going to divide to just give me 1. Or if I think of it this way, I have x to the power of 7 minus 7 is equal to x to the power of 0, which is equal to 1. Because if I have the same thing on the top and bottom, it's just going to give me 1. So anytime I have anything to the power of 0, it's 1, unless it's 0. Alex? So 4 to the power of 0 is just going to give me 1. There you go. The next one asks us to evaluate. Again, this is just stuff from grade 9. So hopefully we can just kind of whiz through this. If you want to kind of get ahead of me on this stuff, that's fine. This is mainly just to figure out if you can use your calculator properly. Again, back to that game. 3 to the power of 4. I can write it as 3 times 3 times 3 times 3. And I can just do it that way. Just multiply 3 by itself 4 times. But likely your calculator has a button that'll make your life a little bit easier. Now maybe my big TI-83 here isn't the best example because you guys can't use this one, but on my TI-83, I hit the 3 button here, and then I hit the little hat or the caret, and then I hit 4. And that gives me 81, which is the same as 3 times 3 times 3 times 3. So those both equal 81. So you need to figure out the button on your calculator which works. So I have another calculator here. This is just a regular scientific one. And on this calculator, I'm going to go 3. And then I have this y to the x button. It might be kind of hard to see. Y to the x. And you can see when I press the y to the x, in my window it comes up as this little hat. And then I can hit the 4 key, and then it gives me 81. So that's another one. I have another Staples calculator here. I don't even know if it works. I stole it from Mr. Beetlestone. Hopefully he won't mind. This Staples calculator, if I am doing the same process, 3, I'm going to hit the little hat, and then 4, and equals, and I get 81. So we get different buttons depending on the calculators. Your button is either going to be a little hat like this, called a caret in math, or you might have a button that looks like y to the power of x, like on my Sharp calculator here. So you need to figure out what the button looks like on your calculator. Likely, it's going to be something like y to the x. There are other buttons that that will sometimes work, but I don't want you to use, like the EXP button here. You can probably see it a little bit. EXP is an exponential power, not what we want to use. So you probably have y to the x, or you probably have the little hat. And that's what you're going to do. So Alex is asking a great question. What does it mean to evaluate an exponent? When we're evaluating an exponent, we're just doing the calculation. If it was something like 2 squared, we're going to go 2 times 2 is 4, and we're done. So the idea here is that when we evaluate, we're going to end up with a number at the end. So what does that exponent turn into in terms of a number? Let's look at a few more examples here. Sorry, I should write in the answer here. This is 81. If I have negative 2 times negative 2 times negative 2 times negative 2, you're going to have 4 negative signs. So if you have a negative number, and you're using an exponent, if it's an even exponent, like 4, 8, 12, then your answer is going to be positive because you have an even number of negative signs. If you have an odd exponent, your answer is going to be negative because you're going to have an odd number. So your first two will cancel each other out, and then it'll be positive, and then you have a positive times a negative. So in this case, you have 2 times 2 times 2 times 2. So 4, 8, and you end up with 16, and it's positive. Just as a bit of an aside, if I had the same question, negative 2 to the power of 3, that would be negative 2 times negative 2 times negative 2. you can see how I have 1 negative sign, 2 negative signs, 3 negative signs. So the first 2 are going to give me a positive, and then I'm going to multiply it by the negative. So I'm going to end up with negative 8. Hopefully you can plug these into your calculator to make sure you figure out how your calculator works. If you can't find the button, we'll do the same thing as we did before, where you just throw in your calculator and model number, and I can go find it online, a picture of it, and we'll figure out which button you're going to use. Taylor's asking the why. So this one's positive. Why does it do that? If I have 2 positives, or 2 negatives, sorry, gives me a positive. If I have 3 negatives, I get a negative, because I have the first 2 are going to give me a positive, and then the third one is going to be the negative. So if I have an even number of negatives or an even exponent, I end up with positive. If I have an odd number of negatives or an odd exponent, I end up with a negative answer. Just a few things coming into the chat here. Me and my brother need calculus screws. I have one, just one on my iPhone. Yeah, that's fine. If you can get through the stuff today, that's good. Go up to fill the blanks to the last minute and get them copied down. You're good. Okay. We'll keep going. Negative 4 to the power of 0 is going to be different than negative 4 in the brackets to the power of 0. So kind of a trick question here, I suppose. How are these things different? And this one comes up a lot. Not a lot. You're going to see it a few times because it's tricky. And we, as math teachers, I'm not sure why we like tricking our students and subjecting them to little sign things, but we do. So when we have something like negative 4, what this really means is, I kind of ran out of room here, so I'll just go up top. This really means negative 1 times 4 to the power of 0. Now, if I follow BEDMAS, I'm going to do my brackets, which I have none. Then I'm going to do my exponents, and I have an exponent here. 4 to the power of 0 is just 1. And I have negative 1 times 1 gives me negative 1. With this guy here, because my negative 4 is inside the brackets, if I follow BEDMAS, I can't break the negative 1 and the negative 4 up because they're inside the brackets. The brackets are important in this question. So because that, the whole thing, anything to the power of 0, so all the stuff in the brackets is being raised to the power of 0, this is just going to give me 1. So it's kind of a weird thing that kind of happens as a result of where the brackets are. And I know it comes up in the learning guide, and it probably won't come up a ton when you're doing your work, but when it does, it's almost infuriating because you're just like, oh, how could I miss that? And you're off by a sign, and you know, it's just kind of cruel. So because everything, the negative 4 and everything else is in the brackets, once we raise it to the power of 0, it all equals 1 because anything to the power of 0 is 1. Whereas the first one really meant negative 1 times 4, and the 4 was raised to the power of 0. That little negative sign floating out front doesn't, it just kind of, you know, gets dropped down, drop down, drop down. We do our exponent, and then the multiplication comes after. So just be aware, it does come up. I just wanted to make sure you knew about it because it can cause some headaches later on. All right, so moving on, c to the 4, c to the 7, c to the 2. All of our bases are the same, so we know we can add our exponents together. Now, the majority of the time when I do problems in class, I'm going to write it like this. I'm going to write it as a little c, and I'm going to write 4 plus 7 plus 2. And I'm going to add them all together, and I'm going to end up with, we get 11, 12, 13, c to the power of 13. So you could conceivably write it out as, c times c times c times c. There's 4, and then 1, 2, 3, 4, 5, 6, 7, and then 1 and 2, and then add them all up, and that would just be a lot of work. So we don't do it that way. We're just going to write it kind of as you see here. The next one's kind of, I wouldn't say tricky, but we just need to make sure when we're multiplying our terms, we have to have the same base in order to add them. So the next example has both x's and y's. So we can't add the exponents of our x's to the exponents of the y's. They're different things. We can't combine them. Just kind of like when we're combining like terms. If you have like 3 a's and another 5 a's and then some b's, you can't combine your a's and b's. Same goes with exponents. We can't combine our exponents unless our bases are the same. So we have some x's here. I have an x, an x, an x, and then I have y and a y. So as I'm going to write this as x, this guy here, it doesn't have an exponent, but we know what exponent it actually has. So because there's no exponent there, we know it's to the power of 1. We just assume it to be there. So I'm going to write in a 1 from that. And then we have a 5. And then we have a 3. So I'm adding all of the x's, exponents, together. And then I have y's. I have a 2, and then I have another 2. And Belle, I saw your question there. I'll get to that just in a second here. I'll finish this one off. X to the 6 plus 3 is 9. And then I have y to the 4. And that is it. Simplifying that down as far as I can go. So Belle, right, you know about the difference between the negative 4 to the power of 0 and negative 4 to the power of 0. What is the best way to put it? It's a good question. How are we going to maybe simplify that or write a note about it so we remember? I guess the important one is here, the second one. Because this one has brackets, we go, brackets means everything. That was an everything. Inside is to the power of 0. I don't know if that helps a little bit. When you're going through the learning guide, you'll see the questions that I'm referring to, and they look exactly the same as these. You'll see one has the negative and then one has the brackets. Just remember the brackets, everything inside the brackets is going to be to the power of 0. It doesn't matter what it is. So I could have like, as just you definitely do not need to write this down, just a completely random set of numbers. Like x times y times 32 times 725,324, all to the power of 0, just going to give me 1. Whereas I had something like, everything in there is just going to be 1. I could have a negative or negative here, or they could all be negative. It doesn't really matter. It's just going to be 1. So I don't know if that helps or not. Hopefully, just maybe one of these things that we just need to kind of remember, I guess. You put 0 to the power of 0 in your calculator and got 1. Alex, I might have to check on that for you. I might have led you down the wrong path. Just trying to think through it on the spot here. I'm thinking 0 to the power of 0 is going to be, it's it's not going to be 1, but we might, yeah. See, my TI-83 is a pretty bright calculator. If I put in 0 to the power of 0, it says error domain. Asked me to quit. So yeah, so math error. Let's try my sharp here. If I go 0, oh, that's not a 0. 0, y to the x. 0, error. Yeah. So I'm thinking, let's try the staples one. 0, hat 0, math error. Yeah, so I'm thinking that's the exception to the rule, Alex. There's a chance your calculator is not as smart as it thinks it is. I don't know. I will, or if somebody's really bored with my lesson, you got this under control, you can go looking online. Why do I have so many calculators? It's a good question. I wanted to make sure you guys knew how to use your calculator, and if I can show you a bunch of examples here, then maybe you have a calculator similar to mine and you could figure it out. If we were all sitting in the same class, I could just walk around and show you the button, but it's a little different trying to communicate through a TV and kilometers of distance and things like that. So, Taylor, so any number will equal 0 if it's inside of the brackets. Equal 1, yeah, that's exactly right. So no matter what's inside the brackets, if it's to the power of 0, you did 0 to the power of 0 and got 1. So it's a calculator thing, I guess. I don't know. I'll look it up for you guys and I'll have an answer for you next day unless you've looked it up online and figured it out. But I'm pretty confident it's you can't do it, it's just 0. Try the default calculator on my computer. Getting to that with my stylus would be a lot of work. So maybe if I have time at the end I can look at it, but we'll see. Let's finish off these questions here. 2 to the power of y, 2 to the 3y. So this last letter C is a little bit different because normally we've had letters or variables to the exponents. Now we have the exponents are variables and our bases are integers. So kind of flip things around. But as long as our bases are the same, in this case they're both 2, we can add the exponents. So what I'm going to do is I'm going to say, okay, my base is 2, I had a y, and I'm going to add to it 3 y's. So how many y's do I have? Well, I had 1, I added another 3, I end up with 2 to the power of 4 y's. So this is just, if I asked a basic question, maybe this is probably a grade 9 one as well, y plus 3y, and I said, combine like terms, how many y's do we have? You'd say, oh, that's easy, 3 plus 1, that's 4 y's. So the rules don't change just because we're dealing with exponents. Same process. I end up with 2 to the power of 4y. Oh, that's brilliant, Abby. Thanks for looking that up. I looked it up, and apparently mathematicians call 0 to the power of 0 an indeterminate form because sometimes they get one thing and sometimes another. So I guess our calculators aren't wrong. It's just not something that comes up a lot. I'll look it up this afternoon and see if I can find not a better answer, but see if I can explain it in terms that that I can understand and you can understand. Because an indeterminate form is just like over my head, and I'm sure it's probably close to over your head. Alex, how do we find 7 to the power of 2 and 5 to the power of 2 as a single power? You couldn't, because they have different bases. We can't combine them together. Because they're numbers to the power, we could actually just evaluate. We could go 7 to the power of 2 is 49, and 5 to the power of 2 is 25, and add 49 and 25 together. We could do it that way, but that wouldn't help us very much. Taylor, wouldn't C be 1? No, we have to keep the base the same. So our base is 2, so we have to keep it as a 2, and then we're going to add our exponents together. So we have you might be confusing dividing with multiplying. Because we're multiplying here, we have the brackets, we're going to add our exponents. If we're dividing, then we're going to subtract them. And that's maybe where you went wrong. You're getting ahead of us here. Let's look at D and E. So they do get a little trickier, obviously. Right, so we have the same base, so we know we can add our exponents. And we should do that. So this is going to be like a simplifying or combining like terms question that you would have seen last year, even some of the stuff we did at the beginning here. Except the like terms are now not just numbers, they're our exponents. So let's see what this is going to look like. I'm going to just write it a little bit bigger. 4 to the power of 2x plus 5, and I'm going to add to that the exponent here, 3x minus 2. Now, our rules still apply, combining like terms. I have x's, I'm going to combine with my x's. I have a 5, I'm going to combine that with my negative 2. My base still stays the same, my base is still going to be 4. I have 2x's plus another 3x's, so I have 5x's. And then I have 5, and I'm going to take away 2. So I have plus 3. So 4 to the power of 5x plus 3. So again, these are things that you know how to do. You've combined like terms before. You're probably really good at combining like terms. It's a question you probably would have seen many, many times. But we get to grade 10, the sort of the next level is now we need to deal with these things as exponents. And it's the same process. Let's look at the next one. The next one, we have 2 to the power of 7x minus 2 and 3 to the power of 2x plus 1. Are our bases the same? 2 and 3, are those the same base? Yeah, and Taylor's on that one. What if the number is different? So no, the bases aren't the same. Can we add exponents when our bases aren't the same? No, we cannot. So if you want to put a little note to yourself, can't add because we have different bases. So there's literally nothing we can do to simplify that question any further. I just put it in there to kind of trip you guys up. Because it will happen when we're going through questions and you know, you have all these different numbers. You'll have 2's and exponents and x's and y's, and you'd be asked to add them all together. And sometimes if you don't have the same base, you just simply can't add them together. There's just nothing you can do about it. So that's as simple as that one gets. Until we know what the x is or some more information, we can't do anything to simplify it. We can't evaluate it. I don't know if it's me wanting to trip you guys up. I'm thinking it's more my knowledge that you guys are going to have a provincial exam at the end of this, and I want you guys to be successful on that test because it's an important test and it's a kind of an indication of the math you know and don't know. So I want to kind of prepare you guys for all sorts of different things that can come up. You can't add the exponents, Taylor, because the bases aren't the same. So we have different bases. In this case, a 2 and a 3. Can't add them together. If they were both 2's, if this 3 here was a 2, then we could add the exponents together. But because it's a different base, we can't add them together. All right. If we fail the provincial, do we fail math? That's a good question. No, you don't. The provincial exam is going to be worth 20% of your final grade. So our two terms that we have are going to be added together. 80% of your grade comes from those two terms. And then your final exam is going to be 20% of your grade. So it's significant, right? 20% is a lot, but it doesn't mean you fail. So the magic number, if you did the math, is 62.5%. If you have 62.5% in the course, and you walk into the provincial exam, write your name on the top of the booklet, don't answer a single question or you get every question wrong. you walk out of the course with 0% on the final exam. That's 20% of your grade. Because you had 62.5, you end up passing the course with exactly 50%. So what I always tell my students is, I will work my hardest, as long as you're working hard, to get you to the magic 62.5%. Give you a bit of a buffer, 65, sort of 66%. And then you don't even necessarily need to be successful in the provincial exam. You still pass the course. And I was having a conversation, we had a staff meeting a few days ago, and one of my colleagues that teaches at Central, he teaches the math program over there. He was asking me, he's like, oh, what math course are you doing with your grade 10s? And I said, oh, we're doing Foundations Pre-Calculus. He's like, wow. And we got to talking a bit, and he's saying, you know what? He said, I believe that even if your students pass, doesn't matter what their grade is, if they pass Foundations and Pre-Calculus 10, that's better than getting 100% in Applications and Workplace Math 10, which is kind of the next step down. So if you guys can get through this course with 62.5% at the end of it, it leaves all of your doors open for grade 11. It leaves sort of all of the post-secondary options available to you. So it's just really important that you guys just work as hard as you can. If you need help, you ask questions, and I promise you that if you're willing to put in the time, I will make sure that you get to that magic number. For some of you, I know this isn't an issue. You have really amazing grades, and you guys have really great understanding. But for those that are really struggling, then it's not a big deal. Your transcript doesn't necessarily suck, as you put it. F&P Math 10, it allows you to take more choices. It allows you to get into more universities. It allows you to go into more trades programs and colleges than an Applications Workplace 10. So even if you're struggling with this math, just keep your kind of that in the back of your head. You get a pass, you get through this course, you leave all your doors open. You get 100% in A&W Math 10, a lot of doors have closed automatically just because you took that course. So I know it's not fun to kind of struggle through a course, but if you feel like it's a little bit over your head, we can get through it, I promise you. You can take the provincial again. So you guys will write your provincial in January. There'll be a rewrite in, I think it's in like April, March, somewhere in there. Or if you don't want to do then, you can rewrite it at the end of the year as well in June. So there are, I think, like 5 or 6 provincial exam writings throughout the year. So same goes with English. If you write your English provincial and you don't think you did very well on it, you get your mark back and you're really unhappy with it, and you're like, well, there's not a lot to the English. I could probably sit down and answer some questions and write an essay again. You can redo it. I think you can redo it twice. I think you get 3 goes at it or something like that. Again, I'd have to confirm that just off the top of my head, but you definitely do have opportunities to redo it if it doesn't go well. But that's not going to happen because we're going to go in, we're going to know what's going on, you guys are going to do just fine. Sorry for that little aside. I'm going to get back in, I'm going to finish this off, and then if you guys have any questions with Unit 1 or anything else like that, I'd be happy to do those. Simplifying. So when we simplify, we're going to have usually coefficients in front. So in this case, we have this the 2 and the 10. Then we have variables with integer exponents, which we're going to add together. So we're just kind of doing 2 things at once here. So hopefully you guys know how to do these types of questions, but if you don't, then here we go. I'm going to multiply the -2 times the 10, and that's going to give me -20. And then I'm going to multiply the x to the power of 3, and I'm going to add the x to the 4, add my exponents together. So I end up with -20 x to the power of 7. So I multiply my coefficients. When I am multiplying variables, I add the exponents as long as they're the same base. So that was the first one. The next one's a division question. 4x to the 3 divided by 2x squared. So we could write it like that, or we could write it vertically if that makes more sense to you. 4x to the 3 over 2x squared. I kind of like writing it this way because I find it easier to kind of visualize what's going on with my coefficients in front, the 4 and the 2. And if I look at this, I can say, oh, well, 4 and 2 have a common factor. 2 goes into 4 twice, 2 goes into 2 once, and I end up with just 2 on the top. Same thing goes here. If I go 4 divided by 2, I end up with 2, but that's kind of why, and I like writing it vertically better. So I have 2, and then my exponents, I have x. Because I'm dividing, I'm going to subtract the exponent on the top, which is the 3, and then I'm going to take away the exponent on the bottom. So I'm going to get 2 to the x. 3 minus 2 is 1. I could write in the 1. That just kind of looks silly. If there's no 1 there, we just assume it's there. So I would probably write this as just 2x. So I divide the 4 and the 2, because they're my coefficients up front. I have the same base, so I deal with my exponents, and because I'm dividing, I'm subtracting those. Letter C. 90x to the 7, y to the 8, 30x cubed, y to the 8. Here we go. What's common between the 90 and the 30? I could probably put 30 into 30 one time, and I could put 30 into 90 3 times. So that deals with my coefficients out front, or 90 divided by 30 is just 3. The next thing I can do is subtract my exponents. Now, we're just kind of getting into this stuff, so I'm showing a lot of steps, but I would imagine a lot of you would be able to just kind of look at it and say, oh, we're going to go 7 minus 3. What are we going to be left with? We're going to be left with the 4 there, and then 8 minus 8 is going to give us just a 0, and that's just going to be 1. So you can do it, maybe I'll just do it twice. So the 90 divided by the 30 is going to give me 3. I'm going to have x to the 7 minus 3, and then y to the 8 minus 8. Oh, getting ahead of myself. So 3x, 7 minus 3 is 4, y to the 0. 3x to the 4, and then anything to the power of 0 is 1. So we end up with just 3 times x to the 4. So that's kind of one way to look at it. The way that I usually do it, kind of the way that works in my brain, is if I just rewrite this, 90x to the 7, y to the 8, over 30x to the 3, y to the 8. I kind of like canceling things when I have division. So I would go 90, 30 is going to go in there 3 times, 30 is going to go in once. I would look at my x's here and I'd say, oh, I have 7 minus 3, so I just cross this guy off and change this to a 4. And then 8 minus 8, I would just cross that off and change it to a 0. And then I kind of look at it and see what I have left. So I had the 3 divided by the 1, so I'm just going to write that as 3. I had x to the 4, and then I have y to the 0, which is going to give me 1. I kind of like doing it that way, but I know I'm skipping a bunch of steps, so whatever you're comfortable with. If you can just visualize it and see where everything's going away and you like canceling things out, then you know you can do it the way I did in the black. If you like to write things down and show all of the steps, you can do it the way I did in blue, but if you do it the way in black, there's a lot more opportunities to make mistakes because you're skipping some steps. So, you know, just use your judgment, whatever you're most comfortable with. Is that it? Oh my goodness. There you go. Does anybody have any questions about adding, subtracting exponents? Anything you had issues with there, didn't understand? Okay, I'm just gonna jump into the learning guide. So if I go back to the course here, Unit 3 learning guide up at the top. I think this is working a lot better in terms of the amount of work you guys are doing. That first unit, we did Unit 2, kind of killed off a few of you guys, which wasn't good. So I kind of like just going through the learning guide. There's extra problems in each of the lessons. If you're having a really tough time understanding, maybe you can just look at some of the solutions and whatnot that are in there for the practice problems. But in terms of homework, I would like you guys just focus on the learning guide. And then if you're struggling and you want some extra stuff to look at, you can go through the practice from each lesson. So what can we do in the Unit 3 learning guide? Well, we can do exponents. We can do negative. We can do multiplying powers. So we're good up to page 2, right, as a single power. You guys can do that. Dividing powers. There you go. So you guys can do basically the first 3 pages. Everything up to raising a power to an exponent. We're going to do that tomorrow. So I know that you guys are eager to get through the Unit 1 stuff. Question 3, page 3 on the learning guide there, Alex, or is that from a different learning guide? Which unit are we talking there? Most of the stuff is things you would have seen in grade 9, just depending on how in-depth your grade 9 teacher went into it. So I don't imagine you'll have a lot of difficulties with it. It does get harder, for sure. Once you get to the end, the questions get really big and long and kind of ugly, but as long as you can remember the exponent laws, you should be fine. When you're multiplying, same base, add your exponents. When you're dividing, same base, subtract your exponents. And we're going to look at a couple other exponent laws, and you just need to kind of remember them. I'm assuming, Alex, you're talking about this learning guide for Unit 3. So if I'm not correct in that, let me know. Question 3, page 3. 1, 2, 3. This guy here, right as a single power. All right, 4 to the A, 4 to the B, 4 to the A, 4 to the A to the 3, A to the 5. So when we're doing this type of question, we're just adding the exponents. Now I haven't downloaded this into OneNote, so I can't write over it, but maybe I'll do A and C because they're a little bit different. 4 to the A, 4 to the B is 3A. So let's look at that one first. So when I am multiplying, I add my exponents. So this is going to be 4 to the A plus B. And I can't add my A's and B's together. So that's it. Just that easy. The second one there, A to the 3, A to the 5. A to the 3 to the 5, I'm going to add my exponents together, 3 plus 5. Because these are both integers, I can actually physically add them, so I'm going to get 8, A to the 8. For the 4 to the A and X to the 4, let's see if I can find the one you're referring to. 4 to the A, 4 to the A? 4 to the A, 4 to the A, got it. So we had 4 to the power of A times 4 to the power of A. Right, so I'm going to add my exponents, same base, A plus A. How many A's do I have? I have 2 of them. So I'd have not just 4 to the power of 2, I'd have 4 to the power of 2A. And A is just a variable. It could be 1, it could be 5. So if we could imagine when you get to the last section in the unit, it's kind of problems involving these sorts of things. If I now tell you, looking at this example, I said, okay, what's the answer?